Hey guys, happy Monday. I'm at Sunny Side Up today, so I am going to still ask you to fill in some notes. So you need your book. We're starting a new section. It's a section leading to trig, trigonometry. So page 187 is where we're going to start. Again, when I come back, I expect that the notes I'm giving you are filled in. There's no excuse for that as I'm literally writing them. And then that you've attempted the assignment problems I've given you. I will still put the answers to the assignment up on pfernandez.weebly.com. Go for it. Just so you know, I've never done a video. This is a first. Why haven't I ever done a video? Because you should listen to me. And when I'm talking, I'm planning for response. Although, at least one of my two classes, I don't get any responses anyway, so I might as well go this way. I'm just messing with you. Speaking of messing with you, I'm sure I'm going to mess up on this several times. Bear with me as we're going to be videoing it together for the first time. So get your books out, page 187. Obviously, if you got to pause this at any time, so be it. Here we go. Angles and angle measures. Some stuff I think you already know, so maybe you can move right along. Here, if you know these things, you don't even need to listen to me. You can just already go in this section to page, well, the page doesn't matter. It's 189 though. And do 10, 11, 12, 13, 14. Because 10 through 14 on page 189 is going to be the assignment I give you here at the end. All right, so do you know what standard position means? You're going to by the end of this. When I refer to an initial side and a terminal side, which really the terminal side is the more important one, once an angle is in standard position. Do you know what that means? And then what about how to find, because identify would be the key skill here, coterminal angles. If you already know how to do that stuff, fine. Go ahead and do the assignment. But everything I'm going to say here is going to be leading to those. Pause as you go, because again, since I'm not getting any student input as I'm talking to just this dinosaur that's in front of me, you might as well pause it if you ever need to along the way is what I'm trying to say. Okay, so here we go. Some stuff you should know. This, easy. Acute angle, duh. Angle looks like this, okay? What could the possible degree measures be? Anything bigger than 0, less than 90, okay? So between 0 and 90 degrees. We know this, okay? Obtuse, we know this. Obtuse angles, something like that. Anything between 180 and 90, okay? It's got to be less than 180, bigger than 90. What about if it's exactly 90 or 180? That's what these are, which again, duh. 90 degrees is a right angle. A straight angle, weird for people, but when you draw just like a straight line, you can think of it as an angle. Like imagine there's a vertex here in the middle. That is 180 degrees, okay? So I could go bigger than 180, but think about it. As soon as I go bigger than 180, if I folded this down, it would just create an acute angle on the other side. So really, or an obtuse angle, I should say. So we should just go ahead and start thinking about things between 0 and 180. That's what we're going to be doing. That's what we're going to be using. So if you understand this, you're already off to a great start. But now let's get into pre-calc type stuff. Stuff I need you to know so that we can do the trig part of this class. Notice the words that I already set up there here, the biggest one being standard position. Basically, I am taking my angle and I am moving it so that it has its vertex on the origin, its initial side on the positive x-axis, and then its terminal side, which that's what matters. That's what we're trying to find, figure out, use. Well, that could go anywhere. In this one, it went here. So look at the angle that that forms. Boom, boom. Just as the same way that I drew them up here, I got one drawn down here where the corner's there, and we got that. Okay? Over here, they drew it here, but interestingly, they're not talking about this angle. They're talking about the long way to get there. So we'll talk about that and what it means. But more than one angle can have the same terminal side. And spoiler alert, it's called coterminal when that happens, but we'll get to that in a minute. First, I want us to go ahead and we're going to draw these descriptions of angles in the standard form. So what's that mean? Standard position, I should say. Corner on the origin. Start it with one of its sides on the positive x-axis, and then who knows where you put the other one, okay? Based on where we put it, though, we're going to talk about the angle measures for it, okay? So, draw them, and then give the degrees. Here we go. 2a is 1/4 of a complete counterclockwise rotation. Complete counterclockwise rotation. That'd be like one entire time around, right? Now counterclockwise, is that when I go this way? Yeah, that's when I go this way, okay? So counterclockwise rotation. I went ahead and I drew these over here, so I'm going to come up here to do this. Again, it said 1/4 of a complete counterclockwise. So corner here, one side here, and now I'm going to go around. So this would be a complete rotation, but I'm only supposed to go 1/4. Well, lucky for us, these things already split into fourths. So we're going to go right here. When we do that, that would make our angle end right there. How many degrees is that? That's pretty clear. That's 90 degrees. I'll write it here, and then I'll come back down here and put it next to that too. Okay, so 1/4 of a complete counterclockwise rotation, that's 90 degrees. Next, B, 1/2 of a complete clockwise rotation. Half of a complete. Well, complete, again, that would be all the way around. So I'm only going half of that. Okay, corner, one of my sides. Now this time it wants me to go clockwise, so I'm going to go from here. Okay, that would be 1/4 of a complete. That would be 2/4, aka 1/2. So there it is. It's going to end there. Okay. Now, when I go and I give the angle measure of this, the fact that I went down from that positive x-axis actually means, and it's written right here, that when we go clockwise, it's negative. Counterclockwise, which we go up from where we started, that's positive. Okay? So in this initial one here, this one was a positive angle, and this one was a negative angle. So when I come back up here, if I'm going clockwise, from where I started, my initial side, I went down. Down is negative. This is not just 180, it's actually negative 180. Okay? Come back down here, write that, and we're off. Hopefully you're getting this. The third one, one complete counterclockwise rotation. Parenthesis, the angle formed by rotating the initial size counterclockwise until it coincides with itself. So coincide just means back where it started. You already know what this looks like, right? Before I even draw it, one complete counterclockwise rotation, well, counterclockwise, we just said counterclockwise, positive. It'll be positive, and one time around, I hope you know this, 360. Okay? So that should be easy. Now let's go ahead and draw it. Again, vertex, one side. If I'm going counterclockwise, I'm going like this. Boom. That's what it looks like to go 360. And since we started by going here, that's positive. Okay. Fourth one, 1/8. But this isn't broken into eighths of a complete clockwise rotation. 1/8 of a complete clockwise. Clockwise. So I already know it's going to be a negative angle. Okay. So I go back over here now. Vertex, initial side, clockwise. So I'm going down. Okay. So when I go 1/8, well, think about it. It's broken into fourths already. So half of a fourth is an eighth. Boom. That's where it's going to end. It's just going to go this far. Okay. I also know that if I had gone 1/4, that'd be 90. So 1/8 would be half of that. This is half, so that is negative 45. Okay. Hopefully you haven't had to think too hard yet. Got to think too hard on this one? Well, we got to think a little differently. 2e. 2 1/3 complete counterclockwise rotations. So this is more than one. 2 1/3. We're going to go around more than once. Okay? So I come over here. Vertex, initial side. I'm going to go around once. Well, that's 360. I'm going to go around a second time. That's another 360. And then I come back over here, and now I'm going to go, after the 2, it's a 1/3 complete counterclockwise rotation. 1/3. Well, let me think about that. 360 divided by a third would be 120. So I'm going to add 120 on there. So I can add those up to get how much it is. But if I think about 1/3 on here, 120. Well, this would have been 90 more. This would be 180 more, but I'm not going to go all the way, right? I'm just going to go 30 degrees past this. So somewhere around there. So this is still the terminal side. That's where it ends. But it's weird to think that it went all the way around. Okay? So it's not actually forming this angle that we drew, but that's the initial and the terminal. It ends up being the same ending place as that one, even though it went around all these times. Now, what is this? 360 plus 360 plus 120. That is 840 degrees. And since we started going up, which is counterclockwise, that is positive 840 degrees. Okay? So we get all those written, hopefully pretty easy, nothing too hard at this point. Hopefully you've drawn these off to the side. I can look at your page and it's going to look basically like my page. Let's flip it now. And when we flip it to the next page, we're going to talk about what I just said here, which is, if I come in here, okay, this place right here, that it ends. It ended when I went once, twice, and a third around. But it also would have ended if I just went 120 to start with. Or what if I had gone one less rotation around? So instead of 2 1/3, I went 1 1/3. It also would have ended here, right? Angles that end the same place are called coterminal angles. So this is the next thing I need you to understand. And while it might seem like a lot at first, eventually it's going to actually help us out. The fact that everything is going to the same place. Okay? So coterminal, kind of another definition. They're angles formed by different rotations but with the same initial and terminal sides. So again, they end the same place. To find measures of coterminal angles, you add or subtract 360. What's that mean? Well, here's what it means. Come back to this one. Okay? This one, I could have just gotten there by going 120. If I needed to get back, I would have gone all the way around again. Wasn't that just like adding 360? And then I go all the way around again. Add another 360. What if I went backwards? Oh, would that be like subtracting 360? Okay, so going all the way around once, or going backwards all the way around once, is just like adding and subtracting 360. That is the key difference. The key thing to remember, I should say. Difference makes no sense. Plus or minus 360. That's what we're doing to get coterminal angles. Okay? Pretty straightforward thing here. There's a little illustration for you to understand why 125 and negative 235 are the same. Because look, they start the same place, because that's what we always do if we're in standard position. And they end in the same place. So even though one's referring to this side and one's referring to this side, they're ending in the same place. They have the same initial. So if you just look at those two things, they're the same. That's what coterminal means. And again, its usefulness will be unlocked throughout this unit. Let's find some coterminal angles for the ones given. Okay? Specifically, they want us to find 2 positive angles and 2 negative angles. All right, how am I going to do that? Pretty straightforward way to do that. Add and subtract 360. So if I'm at 60, I could add 360. 360 plus 60, that is 720. Boom. 720 will end at the same place that 60 did. Okay? I'm supposed to find 2 positive, but I already found, oh yeah, just add 360 again. Add 360 to 720. What does that come out to be? This is a point where I realized I messed up. So instead of delete the video, I do this. I just scratch it out. Make sure that you scratch it out just like I scratch it out. No, sorry. I just got distracted because this is a number that you guys are going to think is stupid, and I don't even want to, just whatever. Weirdos. 420 degrees is the same as 60. That's what happens when I added 360. So it's still what I said, I just wrote the wrong number. So I'll add another 360 to get the next one. I think I was jumping ahead. So the next one, if you add another 360 to that, it's still going to end in the same place. This time it would be 780. Okay? This is different than this angle. This is different than this angle, but they will end in the same place. How do I find some negative ones? Well, keep taking away 360 until you go into the negatives. Let's subtract 360 from 60. That would be negative 300. Boom. Ends the same place as that. Take away another 360. Where am I at now? Negative 660. All of these angles, 1, 2, 3, 4, 5, they all end the same place. Now, do I really need to do this one without your knowledge? Hey, Miss Thomas just walked in. Hi, Miss Thomas. I'm recording a video, so, you know, that stinks. It's cool. It's cool. Miss Thomas is going to stay side up, too. She already recorded her video. She's really the inspiration for me recording this video. Take this moment to Ignore what I'm doing. You could have just skipped ahead 15 seconds by now. But sometimes people come through the door when you're recording the video. All right, back to the paper. I don't think I need to do this one for you. You can do it. Add 360 twice. Subtract 360 twice. When you do that, it's so simple. You get 260. You get 620. If you subtract, you end up with negative 460. If you subtract again, you get negative 820. Okay? All these things will end in the same place as that. All right. Find an angle between 0 and 360 that's coterminal with the given angle. Notice it says between 0 and 360. Again, you will eventually see how this is useful. But when I come back up here and I'm looking at angles like this and this, they're not really useful to me. The whole point of coterminal is we're trying to get to ones that are within one rotation, the first rotation. So those would be ones between 0 and 360. So 890, that's too many things. Let's just start getting down so that it'll be between 0 and 360. So obviously that's going to be less. If I take away 360, am I there? No, that would only be 530 degrees. So while that's coterminal, it's still not quite useful to me. So let's take away another 360 from that. Now when I do that, now am I somewhere useful? Yes, 170. 170 is going to be within that first rotation, which eventually is useful. So once you get and understand what coterminal means, then we can zero in on the ones we specifically want, which are the ones between 0 and 360. Okay? Do it again over here. Again, do I really need to do this? This time it's already negative, so I'm not going to be subtracting more. I'm going to add until I get to something that's the same. So add 360. Oh, you'd still be negative. Add another 360. Yada, yada, yada. Keep adding 360 until you get to something positive. In this case, if you're doing it, it'll be 90. 90 degrees will be what ends up being the same on that one. Okay? All right. Sorry that this is, a lot. And I don't know why I'm apologizing. It's just because I'm confused by videos. But enough about that. Let's go on to the next thing. I already think you understand coterminal. I think that you understand initial side. I think that you understand terminal side. Okay? So that's about angles, solely about angles. I'm going to have you practice that here in a second. Now I want to talk about this word. This word. What is this word? Subtended, or the subtends of an arc. When the sides of an angle pass through the endpoints of an arc, the angle subtends the arc. In the figure below, the arc PQ. This is what the arc PQ is. Okay? It is subtended by angle POQ. So the arc ends at point P and starts at point Q. So this angle right here is what they're using this new word called subtended. Okay? I don't care that much about it as much as I just care that you understand that this angle is tied to this arc. Because we're going to talk here about the length of this arc, and we're going to use the fact that we know how to find angles to get it. Okay? So if you think about it, up here, what do we know about the entire length around a circle? Well, the entire length around a circle is 2 pi r. Okay? But I don't want the whole thing. I just want this much of it. So in like fraction world, I would want this much over the whole thing to get the total. Okay? But I don't know how much this is. That's what I'm trying to find out. What I will know is the angle. Well, how much is an angle all the way around? 360. So if I go ahead and I take this, I can think about that as a fraction. Okay? In this much of the angle over 360 would give me a fraction of the total, the same proportions as this over 2 pi r would give me. Okay? So this angle right here, whatever it is, if I took it and I divide it by a total rotation all the way around, that would give me some fraction, some percent of the whole. If I take that percent and times it by that, it's the same percent in this angle as this arc all the way around. Everything I'm trying to explain here really just leads you to this. Angle, radius, because you got to use the radius to get 2 pi r. Okay? That will give you vice versa each part. It'll give you this length, or maybe there'll be somewhere we know the length and we're trying to find the angle. Okay? It'll be useful, I promise. Let's go down here and see. Oh, thank you, Springboard, for giving us something exciting like a pet gerbil. Okay? So in the like 2 or 3 weeks that a gerbil lives, it runs the length of an arc on a circular wheel with a radius of 12.5 centimeters. There's r. which subtends a central angle of 40. There's n in the equation. Okay. What length did this gerbil travel? So visually here, there's a wheel. Here's my initial side of my vertex. It is going 40 degrees. Well, 40 degrees is only about this much. Okay. It ran that much of the wheel. Not very much. Okay. How can I figure out how much that is? Well, this angle is 40/360ths of the whole. 40/360ths. Which means this will also be 40/360ths of the total all the way around. But we're not thinking in terms of 360, we're thinking in terms of 2 pi r. If I times this percentage by 2 pi r, it'll leave me with this much. That's what we're doing. Okay? 2 pi r in this case is that. If I turn this into a decimal or a fraction that I time that by, it gets me 8.7. Boom, I'm done. Get it? Don't get it? Let's do some. Okay? Find the length of each arc. So this arc. And in this case, it looks like this arc. Okay. To the nearest hundredth of a unit. So our units in this one are inches, our units in this one are centimeters. All right, just follow this thing. If you don't understand the reason behind it, just go up there and go, I know it's n over 360 times 2 pi r. Okay, so in this case, n is 60. 2 pi r is 2 pi times 8. Just plug it in. Just figure it out. When you do that, you're going to get 8.38 inches. Okay? So this would be a great time where you pause for a second and you set this one up. Are you doing it? That's why I paused there in my voice. Set this one up. I'll be back with the answer, but pause it, do it. Answer coming in 3, 2, 1. Here's the setup. 210 over 360 times 2 pi times 30. Do all the math, it should come out to 109.96 centimeters. Okay? Again, when I'm saying you to do that, pause the video, try it, please do. That's how we do this. This is how we get these arc lengths. Okay? So, one more. A wheel with a radius of 20 inches rotated 80 degrees is rolled along the ground. How far did the wheel travel? All the pieces are here again. R, in, okay? Plug them in. Don't even make too much of a deal of it. Plug it in. See if you can figure out why the answer is 27.93. If you don't, you should rewind. Come back up here. Look at this equation. Understand what I'm doing to plug that in. What does this represent? Well, if a wheel is turning, so it's like going here on the ground, when it turns, the same like arc length is going to be the thing that's like making an imprint on the ground as it rolls, right? And that's what it's saying, is this length ends up being the same as that. So more on that later, but hopefully you get how to now subtend angles. To really find out if you do, okay, on the next page, that's not that page, on the next page, there's 6 and 7 at the top, okay? I want you to go ahead, read these, think through them, write down some answers. On that last example, I paused and then I said that the answer was coming. Okay, in this case, that's exactly what I want you to do. Now, they stretch your thinking. They make it into a clock. But I'm now going to go ahead and I'm going to say that answers are coming your way after you pause it and try it. Answers coming in 3, 2, 1. All right, here we go. How many degrees does the second hand rotate in 4.5 minutes? Okay, this goes back to the first thing we talked about. 4.5 minutes, the second hand rotate. If it's starting here, okay, and it rotates 4.5 minutes, that's once, twice, 3 times, 4 times, and a half, all the way to here. Okay, how many degrees is that? 360 plus 360 plus 360 plus 360 plus, oh, it only went half the last time, that's 180. Add all those up, it would go 1620. That's 1,620 degrees. Okay? How far does the tip of the second hand travel? Now, if when you pause this and you read that, you had no idea, think about what the tip is doing. The tip isn't making an angle. The tip is actually traveling the distance that I drew here. So we're going back to that last thing we said, and we're talking about that this angle basically is subtending the second hand. So the tip of the second hand, as it goes around, the distance, like the tip of it's going to travel, goes right into our equation. Let's use 1620. So 1620 over 360 times 2 pi. In this case, how far is it? We're talking what? We're talking about what represents the radius. Okay? Well, up here it tells you the radius. The second hand is 6 inches long. There you go. There's your equation to set up. Plug it in. And when I'm saying plug these in and I'm just immediately giving you the answers, you should really be trying to type these in your calculator because there's going to be some confusion with fractions. There's going to be some confusion with pi. So make sure that you're typing this in. So I'll pause right now. Get it out. Go ahead. Type this exact thing in. If you need to pause while you do it, so be it. I will write the answer immediately after this. It should be 169.56 inches. Okay? Again, hopefully you're getting that. I'm going to go ahead and show you 7. That was one I also assumed when I paused the video that you had understood. If you didn't, maybe pause now and figure it out. Hey, what's the length of the major arc AB? Maybe you'll know what a major arc means. Okay? In this case, you're still just trying to find how far around AB is. So here we go, from A to B. Okay? A to B comes around like this. What's the radius? Looks like 1, 2, 3, 4, 5. So we know that R is 5. What's the angle? Well, with B, it looks like B is at about -3.5, +3.5. Hey, that means that it's halfway around here. So 90 degrees, okay, and then half of that's 45, so 90 plus 45, what's that equal? 135. That's going to be our N. There's our two things to plug in. Plug them in. When you plug them in, go ahead and you get 135 over 360 equals 2 pi times 5. Okay? So again, hopefully you're typing this correctly. If I'm typing it, this is how mine's looking. Okay? It's looking like the fraction, I put it like this. Okay? Then I times it by the other thing. So I'm going 2. I find pi. Okay? And then times 5. There's a number of ways you could write this, but I'll write it like that. Okay. What does this come out to be? Boom. It comes out to be 11.78. Is that in what? What length is it? Oh, we don't have any length, so we're just going to say units. Okay? Now, it's quite possible that major arc actually means going around this way. But you know what? I'm not concerned with that right now. Right now, I just want to make sure that you know what this was, because I'm not trying to teach you major arc at the moment. Note for next year, when you reshoot this video, major arc means you go around that way. It's not important, though. Moving on! 8 and 9 are a check your understanding. I think at the beginning of the video I said to do 10 through 14, but I'm just going to throw 8 and 9 on there too. So at this point, it's yours to do. Do them. On the regular website, pfernandez.weebly.com, I'm going to post the answers. Okay? So this is up for you and do. More videos to come? Oh, absolutely. In the meantime, behave. If you're done with the video, sure, you can rewind and look at it, but I still hope that your phones are not out. The sub is trusting you to work on it, and I'm trusting you to do it as well and check your answers. Have a happy Monday.